Okay. All right. Today we are looking at simplifying rational expressions, which is basically factor. Essentially, what we're doing is going back to what we have really is we're reducing fractions. If you had like 14 over, let's say, 40. What we're doing is we're taking our numerator and denominator and we're writing them as factors, bubbles. In this case, 14, I might rewrite as 7 times 2. So those are our bubbles that we're doing. We're factoring. And 40, I could write as 20 times 2. Again, we're factoring here. And what happens is when you get a common factor on top and bottom, those bubbles pop and they reduce. And we are left with 7/20. And it's a reduced simplified fraction. And that's exactly what we're doing today, except for the fact that we're using polynomials and factoring polynomials instead of just factoring integers. Okay. So a rational expression is a quotient of two polynomial expressions. I like to say rational fractional, mostly because it rhymes, but also it gives us a good idea of what to call these things. So because it's a fraction, it's a rational fractional expression. All right, so she says to recall that x plus y and y plus x is equal to 1. I don't know if you maybe know that. But what we have here is we have the same thing on top and on bottom. Does it matter that it's x plus y versus y plus x? No. I mean, it's essentially saying, hey, 3 plus 5 over 5 plus 3 is 8 over 8, which is 1, right? Okay, so that's essentially what that's saying. I don't really like this one, how she wrote that. These are not the same bubbles, okay? What is different about these?
One x is negative and one y is negative.
Yeah, so here, up in the numerator, the x is positive, but down here, the x is negative. On the numerator, the y is negative, and here, the y is positive. So what these are actually called are opposite factors. They are exactly opposite, okay? How do you deal with this? So here's how you might see it. Like maybe you see 2 minus x over x minus 2. You might approach and see something like that. These look very similar. These are opposite factors. Let me show you how they simplify. So what I'm going to do is I'm going to rewrite this as negative x plus 2. So I'm writing it in standard form, standard order. And then what I see here, I have a leading negative. What am I going to do every time I have a leading negative? Take it out as the greatest common factor. All right, so I'm going to go ahead and take off that GCF. When I take out the negative 1, I'm left behind with an x. And if I take a negative 1 out of the positive 2, what am I left with? Negative 2. My denominator, I get to leave the same as x minus 2. And so what happens here, by taking out that negative 1, you can see now my bubbles match. And those bubbles will reduce because they are identical. Okay, and what are we left with? We're left with a negative 1. Okay, so anytime you see opposite factors, do you have to go through this whole process of writing it in the right order and factoring out the negative? You have to do that? No, because if you see opposite factors, it's always just going to reduce and leave behind a negative 1. Okay, so that'll probably come into play here. But everything we're doing today, factor. is how we start everything. So, number one, I have 64k cubed minus 1 over 4k squared minus 13k plus 3. And I need to factor first. Must. So, factoring first. In the numerator, what type of factoring do we need to do here? What do you notice? Difference of cubes. They are perfect cubes. All right, so that's going to be small bubble, big bubble. Small bubble, big bubble. And what are the signs for subtraction? Minus, plus, plus. Very good. Minus, plus, plus. All right. What cubed gives me the 64k cubed? What times what times what gives me 64k cubed? 4k. 4k. Like my dream TV. And what cube gives you 1? 1. 1 cubed is 1. Okay. And then what do we need to do to fill in the big bubble? 4k squared. What is 4k quantity squared? 16k squared. Multiply in the middle, what do we get? So ignore the signs. We took care of the signs. 4k. That's it. And then square the last thing, we get 1. Okay. Yeah, so when we do our pattern, the pattern takes care of the signs. Yep. In the denominator, we have a trinomial. That trinomial means we just need to double bubble. First times first has to be 4k's. Oh, you know what? Look at this. 4 times 3 is 12, which is 1 away from what we want. So we want to keep, we want the 4 and the 3 to multiply. So I'm going to keep that as a 4k times 1k. 4k times 1k gets me my 4k squared. And last times last has to be my positive 3. What times what gives me positive 3? Negative 1 and negative 3. If we wanted the signs have to be the same here. How do I know if I did it right? Check the O and the I. Let's make sure we did it right. 4k times negative 3 is negative 12k. And negative 1 times k is negative 1k. When we combine those, do we get our number? Yeah, we got our 13 right there. Our negative 13. Okay. Great. Does it, what would you say? 4k minus 1. Very good. Top and bottom. Boy, she started out with a real tough one. So we're left with 16k squared plus 4k plus 1 over k minus 3. That is the final answer. Do not just cross crap off, ladies and gentlemen. You cannot do it. It has to be written as a product in order to be able to pop bubbles, essentially, okay? You cannot say, hey, there's a k here and there's a k there. Let's just cross them off. You cannot do that. It's because they're not connected with multiplication. There's a plus sign there, okay? So we need products. And when things are written as products, then we can reduce them, okay? So don't just cross crap off. Don't get cross happy crappy. Okay. Number 2. What do you notice about the numerator? You can take a 12 out. There is a greatest common factor. Greatest common factor first. You absolutely want to look for those. We can take a 12, and what else can we take out? An n. So if we factor out a 12n, I'm going to put an equal sign just so we know these are equal. When I factor out the 12n, what's left behind? N minus 12, 24, 36, 4. There it is. Okay. N minus 4. How do you know if you did this right? Multiply it back in. Distribute. All right. In the denominator, what do you notice in the denominator here? 18. Yeah, they are both divisible by 18. What else? There's a GCF there as well, huh? All right. So 18 n squared. Very good. Okay, we take out the 18n squared. 16 minus 1n squared. Good. Now look at that. What do you notice about the 16 minus n squared? Sasha?
It's greater square.
Difference of squares. Yep. Yep. Difference of squares. Perfect squares. So again, we're going to double bubble that. I'm going to rewrite here. 12n times n minus 4. Boy, she really, it's tight on space, isn't it? It's a little tight for my taste. So I'm going to double bubble. How does, let's see, first times first has to be 16. So what times what is 16?
4.
4 and 4. And then last times last has to be negative n squared. What's that? Negative n and positive n. Okay? So, do we have a match?
Yeah.
It's switched. So, we got almost a match. Okay, it's almost a match. We have opposite factors. Right here, we have a positive 4, negative 4. We have a positive and negative n. These are opposite factors. They reduce, but they equal negative 1. So we're going to write in a negative 1 because those reduce and leave behind a negative 1. What else cancels here? The 6, yeah. So the 12 and the 18, we can reduce by 6. So 12 divided by 6 leaves behind a 2. 18 divided by 6 leaves behind a 3. What else can reduce here? An n, yes. We have an n on top, and we can cancel one of our n's on the bottom. And again, I just told you don't cross crap off. How come I'm allowed to cross crap off here? It's multiplied, right? This is 12 times n times the bubble. So we can cross things off there. And let's see what's left behind. In the numerator, I have a negative 1 times 2. That's negative 2. And in the denominator, I have a 3 times my bubble 4 plus n. And that is a beautiful answer. Oh, and I forgot an n.
Yeah, thank you.
Thank you. I forgot an n. We only crossed off one of those. So 3n times the bubble 4 plus n. Whew. Okay. Let's look here. Now, we are multiplying and dividing fractions. And we have some instructions. Oh, any questions on the first two? No, it's just a lot of factoring. A lot of great factoring practice. In the denominator, or in the, yeah.
So when you do like the subtraction number, like there's a negative one. How do you know to put the negative one?
Well, if I could have written 2 times negative 1, like that. I could have written it like that. And then you just multiply and clean it up. But usually we put them into the, yeah. Oh, is that what you're asking? Like, does it go on top or bottom? So let me ask you a question then. One of these things is not like the other. Negative 1 over 2. Negative 1 over 2. 1 over negative 2. And negative 1 over negative 2. Which one is not like the others? Sasha?
The last one?
The last one. The last one is the only one that is wrong. Okay? Why is this one wrong?
Is the divided term positive?
It would turn positive. Negative divided by negative is a positive answer. Where does the negative go? It doesn't matter. It's the right answer. It goes up top. It goes out in front. It goes on the bottom. They're all the same. They're all equal. Traditionally, you put it on top or on front. But what I need you to know is that these are all the exact same thing. And if I had written my negative down here with negative 3n, that's still the same thing. Still the same thing. So that's a good question. All right. Yeah.
And make us do the, like it doesn't equal.
Oh, so we will be talking about that. Yes, there are, they are, simplified. You're right, they're not perfectly exactly equal in all respects. So there are some undefined solutions, and we will be doing that in the next unit. Okay. Okay, so we have multiplication. For multiplication, we are going to factor and then simplify. And then for division, we don't divide by fractions. We multiply by the reciprocal, also known as keep, change, flip, in case you forgot. And that's what we're working on today. All right. First fraction here. I have 3 terms. What should I do? Double bubble, yes. Double bubble. I know x times x is x squared. What times what gives me my negative 24? Negative 12 and negative 2. Beautiful. Negative 12 times negative 2. I'm going to save myself. Let's see. Oh, what do we have here in the denominator? What do we need to think about? Oh, you're right. Thank you. Yeah, that would be better. That would work a lot better. In fact, it would be right instead of completely wrong. Thank you. All right. You okay, Sam? Did you just eat a warhead again?
No.
Oh, okay.
I'm
warhead
fine.
done?
No, I'm fine already. Your daughter at home.
All right. On the denominator, what do we notice in the denominator? You can pull out in x squared, greatest common factor, GCF. Let's take out the x squared. What's left behind? X plus 2. Very good. All right. In the numerator, in the second fraction, what do you notice up there? Greatest common factor. You can pull out a 5x. Let's take out the 5x. What's left behind when you take out the 5x? Good. X minus 4. Beautiful. And here I have a denominator. I have a trinomial. What do we need to do? Double bubble. Very good. I loved it. You used my phrase. I learned that from a student. I don't know how many years ago. But the minute she said it, I was like, oh my God, I am always going to use double bubble. It's so good. All right. First times first has to be x squared. So that's x times x. What times what is going to give me that positive 48? 12 and 4. In fact, negative 12 and negative 4 would be a great one there. Negative 12 and negative 4. All right, good. Yep. It's okay. I did it on the last one. Yeah, because everything is multiplied together. Now we can cross stuff off. What are we going to cross off here? And the bubble, x minus 4, top and bottom, that reduces to 1. What else?
X plus 2.
X plus 2 and x plus 2, those reduce to 1.
Would you?
Yes.
You stole my question.
So what happens here is I could throw in a whole nother step if I wanted to, where I just write like the 5x in front, and then the bubble x minus 12, and x plus 2, and x minus 4. I could just rewrite all of them, and I don't want to do that. Do you? So we're just, it is all multiplied, as you said, Avery. So all of these, we have an x minus 12 on top and an x minus 12 on bottom, and those are going to reduce as well.
Wait,
okay?
can we just end up with x squared times 5x?
So what else can we reduce here? Oh, the x on top and one of the x's on the bottom. Oh, yeah? Okay. And so we're left with, in my numerator, the only thing I have left is 12. And in my denominator, the only thing I have left is an x. And that's it. So I could say there's a 5 times a 1. Times a 1. Times a 1. Yeah, times a 1. Yeah, right? But it's once I clean it up, it's just still 5. Uh-huh. All right, very good. All right. Here we go. All right, look at that. Number 4 here. I have a difficult, hard trinomial here because we got a leader in front, but look. I'm looking at the product. Multiplying 5 times 6, what do you get? 30, which is 1 away. 1 away. And if you're 1 away, it says keep those numbers as a 5 and a 6. So 5p times 1p gets me my 5p squared. What times what gives me a negative 6? And I want to keep the 6. 6 and 1. Let's do, we want positive. I want a big positive number here. So I'm going to put positive 6 on the outside and negative 1 on the inside. How do I know I did it right? Check the OI, the outer and the inner. So on the outside, I have 30p, and the inside, I have negative 1p, and that's where my positive 29 comes from. Okay? Are you good? Oh, now look at the denominator. What do you notice? It's the same thing. It's a 1 away. So double bubble here. 5p times 1p gets me my 5p squared. Last times last has to be positive 5. What times what is positive 5? Negative 5 and negative 1. And again, I wanted that outside product. I wanted it that nice big 25 there. So negative 25p and a negative 1p, and that's where I get my negative 26. Okay? All right. Numerator 2. What do you notice? Greatest common factors. Thank you for using the lingo. What are we taking out?
3p.
3p. All right, what's left behind? P minus 5. Very good. I almost went with the 3. You had me convinced. All right, P minus 5. Very good. Denominator. What is that? Difference of squares. Very good. Double bubble here. Double bubble. What times what is 36? 6 times 6. What times what is negative p squared? Negative p and positive p. But you choose a different letter. All right. What cancels out? What reduces? Sasha?
5p minus 1.
5p minus 1.
And p plus 6.
P plus 6. Yes, exactly the same as 6 plus p. Are those opposite factors? No, they are identical. Just a different order. So those all reduced to 1. Very good. What else?
P minus
P minus 5. Very good. Top and bottom reduces to a 1. And I think that is all. So we're left with 3p over 6 minus p. Can I cross off these? No.
These one plus. Wait, never mind.
Nope, this one's connected by addition or subtraction. It's not a product, so that is the final answer. Very good. All right. So for division, here we have a couple of division problems. Keep the first fraction, change the symbol, and flip. We're going to make sure that we flip the second fraction. Keep, change, flip. So in my numerator, my first one here, I'm going to double bubble. Hey, it's a 1 away. So I have 2s times s is 2s squared. And I'm going to 4 times 1. So I want the 4 on the outside and the 1 on the inside. Did I do it right? Yeah, 8 s's plus 1 s gets me my 9. What about the denominator? Difference of squares. Very good. Double bubble. 1 times 1 is 1. What times what is negative 4s squared? Negative 2s and positive 2s. Oh, see, it's just really bad letter choices because And they look so similar, right? It really just messes with my dyslexia. So, all right, we are going to change the sign to multiplication, and my denominator is going to go upstairs here in the numerator. We're going to double bubble. I'm looking at 2s squared minus 3s plus 1. And again, that's a 1 away, so keep those numbers as they are. 2s times s is 2s squared. And negative 1 times negative 1. Did that give me the right thing? Negative 2s and negative 1s is negative 3s's. That's right. All right. My numerator is going to come down here to the denominator. I'm going to double bubble it. And again, this is a 1 away as well. 2s times s is 2s squared. What times what is negative 1? Negative 1 and positive 1. I want the negative 1 on the outside and the positive 1 on the inside. So I got negative 2s plus 1s is negative. Okay. Are we good? Yeah? All right. What reduces?
The 2s plus 1.
So I see a 2s plus 1 on top, and I see a 1 plus 2s on bottom. Does that reduce?
Yep.
Yeah, sure can.
Wait, can we also include that?
So you can pick one or the other. You can't do both. Yeah, it's 1 for 1. 1 on top, 1 on bottom. I could have chosen that one. Okay. So here we have 1 minus 2s, and here I have a 2s minus 1. Those are opposite factors. So that one and this one reduce with a negative 1 left behind. I have not done the s minus 1s. S minus 1 on top, s minus 1, those reduce to 1s. That's nice. Is that it? Okay, great. All right, so on top I have a negative out in front, and then s plus 4 on top, and then in the denominator I have a 2s plus 1. Is this a perfectly acceptable answer? Oh, you can't see that. There you go. Good? All right, great. Are you good, or do you want one more?
Good.
You're good? Okay. All right, that's fine. The last one is, the last one, number 6 has, this one, when you let me just do this first one. This is difference of squares. It factors as k squared and k squared, negative 4 and positive 4. And so, yes, you're right. Well, that k squared minus 4 goes again, double bubbles. Okay? So you would get k squared plus 4, and then the k squared minus 4 becomes k plus 2 and k minus 2. Okay, so that was a double difference of squares. I don't know. Let's call that.